This experiment focuses on learning how to use the vacuum line. To do this, we look at one particularly useful application, the measurement of vapour pressure. All substances have a vapour pressure. It is a property of the substance that quantifies the extent to which a substance is in equilibrium with its vapour phase. The higher the vapour pressure, the more volatile a substance is. Vapour pressure arises as molecules from the surface of the liquid, or indeed solid, rip away from the surface. This is achieved by overcoming the intermolecular forces holding the liquid together. When in the vapour phase, these molecules may re-enter the liquid phase, and so a dynamic equilibrium is established. The vapour pressure is simply a measure of the extent to which the equilibrium is shifted to the vapour phase. Vapour pressure is of particular interest in considering automotive fuels. These are pumped out at gas stations, and hence there, at the point of pumping, the liquid may enter the gas phase. You'll know this because you'll smell petrol while you're filling your car. This is because petrol has a high vapour pressure. In general, the higher the vapour pressure, the more likely shift to the vapour phase will be. Hence, it is of environmental concern to consider the vapour pressure of fuels to minimise this pollution source. Given that vapour pressure is due to molecules moving away from the liquid phase, it makes sense then that this is dependent on temperature. As we increase the temperature of the substance, we are giving the molecules more energy, and hence increasing the probability that they will overcome the intermolecular forces maintaining the liquid phase. This continues until the substance temperature reaches boiling point and the liquid enters the gas phase. The extent to which the intermolecular forces maintain the liquid phase are of course reflected in the enthalpy of vaporization, and the pressure-temperature relationship is quantified by the Clausius-Clapeyron equation. Therefore, to use this equation, we will need to record several vapour pressures over a range of temperatures. The vacuum line allows us to determine the vapour pressure, as it allows us to measure the extent to which the vapour phase forms when the entire system is under vacuum and hence unaffected by air or other gas phase molecules. This approach is also useful for removing air from a liquid for synthetic reasons or for photochemical studies, which often have to be done in the absence of oxygen, a very efficient quencher of excited states. It's a very simple, elegant experiment, and it's a great one for teaching how to use the vacuum line. Detailed instructions on using the vacuum line are in the Technique pre-lab video linked in the electronic lab manual.